Okay, good afternoon to everyone. So today we'll be continuing with quadratic polynomials, and then we'll go on to the further topic of cubic polynomials and how we can figure out the roots and factors of those polynomials which have they have higher degrees. For example, it's x raised to 4 plus 3 raised 3x cube, similar to those kinds. Okay, so we learned yesterday the quadratic formula. If we have to solve any polynomial, any quadratic equation which is of the form ax square plus bx plus c is equal to 0, that x can have two values and x can be at most two values, which can be either real or imaginary depending on the formula I'll be writing now. And x will be equal to negative b plus or minus the square root of b square minus 4ac whole over 2. Now, b square minus 4ac is also referred to as the determinant of the quadratic polynomial. So, it is and if we know some things about the determinant, we can figure out a few more properties of what the roots of the quadratic polynomial will be there. For example, say b square minus 4ac is equal to 0. Now, b square minus 4ac is equal to 0. This will be root 0. And you are doing, say, negative b. Negative b is intact, but negative b plus or minus 0, it doesn't matter. That means you're just getting one equal root. So, the roots will be equal, and there'll be only one value which will satisfy the quadratic equation. Now, if b square minus 4ac is greater than 0, if b square minus 4ac is greater than 0, then your roots will be real and they will have certain values. For example, let's say b square minus 4ac is 5. So you'll get root 5, although that is an irrational number. But still, if you draw a kind of table, you'll be able to see that even irrational and rational numbers both fall under the bracket of real numbers. But if b square minus 4ac is lesser than 0, you can't find the root of a negative number. The root of a negative number is a complex imaginary number, and the roots to a polynomial by b square minus 4ac is lesser than 0, that it'll have like imaginary roots. It doesn't have the root. It doesn't have real numbers which can satisfy the quadratic equation ax square plus bx plus c is equal to 0. Fine?
Shakram, can you use a darker chalk? Because it's very hard to see.
Okay, fine. Better?
Yeah.
Yeah, kind of better.
Now that is it with quadratic equations, but still, let me discuss a few problems which you may have seen in the worksheet. First of all, any doubts, you come to me with the exact question. Don't tell me the question number. Tell me the question in language. Anyone with the doubt in the worksheet?
Oh, yeah, I have doubt.
Yes, Shreyansh. Can you tell me the question?
Oh, yeah, so I have a doubt in the first question. If 1 is the root of the equation, ay square plus ay plus 3 is equal to 0.
Just a minute. Ay square plus ay plus 3 is equal to 0.
Yeah, and y square plus y
Square plus y
plus b is equal to 0.
is equal to 0.
Then find the value of ab.
A into b.
Yeah.
Okay, fine. So if you know that a certain number is a root, that means instead of y, I can put 1. Right? So what I can do here is ay square, I can replace with a1 square, which will be a, plus a into y, which is again a, plus 3 is equal to 0. So from here I can take that 2a plus 3 is equal to 0. And then I can figure out that a is equal to minus 1.5. And then similarly, y square plus y plus b is equal to 0. Y square again 1 plus y, which is 1, plus b is equal to 0. So b I can say is minus 2. and then you can say that AB is 3, fine? See, when you're given a number and said that it is a root of a certain quadratic equation, what you have to do is you put that same number inside the quadratic equation, replace it. For example, I can see AY square. So if it's AY square plus AY plus 3, then you can figure out that it's not A which is the variable on which the quadratic polynomial has been based, but it's Y. So you have to replace Y with whatever value they have given to you, and then you can go on with whatever they're asking. For example, in this case, they asked what is again to be, right?
Yeah, I didn't get how did you get 3?
Get what?
3.
Minus 2 into minus 1.5. 3 only, right?
Okay. Okay.
Fine?
Yeah.
Any other tips?
Yeah, I have a doubt in this question. One second. Yeah. A and B solved a quadratic equation. In solving it, A made a mistake in the constant term and obtained the roots as 5, minus 3.
5, minus 3, okay.
While B made a mistake in the coefficient of x and obtained the roots as 1, minus 3. The correct roots of the equation are.
Okay, fine. This is also a very a question where you have to use your analytical thinking, but it can be sorted out. So, is the constant term. So, let it be ax square plus bx, ax square plus bx plus c is equal to 0. So, the first guy A, he made a mistake in writing c. But we know that his ax square plus bx will be correct. Now, we learned yesterday that if the roots of a quadratic equation are alpha and beta, the sum of the roots will be minus b by a. They said only he has made a mistake in the constant term, but he did not make a mistake in b and a, correct? Right?
Yes.
Okay. Now they are saying the roots are 5 and minus 3. So if we have not made a mistake here, we know that alpha plus beta, we can say, will be the roots which he has got, which is minus 2. This is certain because he has not made a mistake in writing what is b and what is a. And similarly, the other guy, he made a mistake in writing the coefficient of x. But we know that the product of the roots is c by a, right?
Yes. And how did you get minus 2?
Minus 2, 5 plus, oh sorry, okay. Plus 2, fine?
Okay.
5 plus minus 3, fine?
Yes.
Okay. And we also know that alpha beta will be minus 3. 1 into minus 3, minus 3, okay?
Okay.
Now I had also taught that any quadratic equation can be also made of the form x square minus alpha plus beta x minus alpha plus or plus alpha beta, right? Is equal to 0. Right?
Okay.
Now I can replace, so x square minus 2x.
Can you move the camera down? I cannot see what you are writing.
Okay, now.
No, okay, more down.
Okay, fine. I'll clear some space up.
Okay. Yeah, sure.
Okay, so alpha plus beta is 2 and alpha into beta is minus 3. So I can make it like x square minus 2x minus 3 is equal to 0. Fine?
Okay.
Now you can solve by the quadratic formula. It will be 2 plus or minus the square root of 4 minus 4ac. It will be plus 3 into 1 into 4. So plus 12 whole divided by 2. So 2 plus or minus 4 by 2. So 1 plus or minus 2, which will be either 3 or minus 1.
Shaktam, won't it be x square plus 2x?
No, it's I thought no, it's x square minus of alpha plus beta into x plus alpha beta is equal to 0. Because only then you'll get x minus alpha into x minus beta is 0. And from there you'll get to know that x is alpha or beta, right?
Okay.
So it will be x square minus 2x minus 3 is equal to 0. And from there you'll get 3 and minus 1. What root did A get? 1 and minus 3. Oh, B got 1 and minus 3. Okay, fine. Got it? How to solve this one?
Yeah.
Other doubts?
No, I have no more doubts.
Okay. The others, did you any doubts while solving the worksheet? There are a few questions on lines also. Any doubts on them? Yes, anyone? No one? Okay, fine. So I'll move on to give a few more problems which you may have found, which you may have solved, and let me see how you went through them. Just a minute. I'll just get those problems. Give me a minute. The point, okay, this one was good. The point on the x-axis, which is equidistant from 2 minus 5 and minus 2 9, is given by 6 0 8 0 minus 5 0 or minus 7 0. Did all of you solve this? All of you solve this?
Can you tell the question number?
It seems it is the third question in the document.
Okay.
After find the ratio in which the y-axis divides a line segment joining the.
I solved this.
The question after that, the point on the x-axis which is equidistant from 2 minus 5 and minus 2 9.
This question, na? Third question.
Yeah, third question.
Yeah, I solved it.
Okay, so it's simple. You can plot it on a graph. You can plot it on a graph this way. And the point 2 minus 5. 2 minus 5. So will be somewhere fourth quadrant. Say minus 5 is here, 2 is here. Minus 2 minus 5. And then minus 2 9. So minus 2 9 this side. And we extend this arrow a little bit. 9 is here and minus 2 is here. And this is minus 2 9. Now after this, Vedant, did you solve this?
Sorry, I was traveling yesterday all day, so I didn't get any time.
Okay. Om, did you see this question in the worksheet?
Yeah, I saw.
Yeah, so how did you go about it after getting to know that 2 minus 5 and minus 2 9?
By using the distance formula.
Okay, distance formula. So distance formula 2 minus 5 and minus 2 9.
X2 minus, that's one, right? X2 minus x1 whole square.
X2 minus x1 in this case will be minus 2 or whatever, because anyway it's getting squared.
Yeah, it'll be
Minus
same.
2 minus 2, 16 and minus 196, right? 16
0 minus. Yeah.
So root of 212. Yeah, root of 212. And
Second.
2 root of 212 by 4 will be 53.
Yeah.
2 root 53, right?
1 second. 1 second, let me see the question once.
Point on the x-axis which is equidistant from these 2 points.
So they are the point on x-axis. So point on x-axis means the y-coordinate will be 0.
Okay.
So the y-coordinate would be 0. So now we have the distance formula, right? So we could use minus 2 comma 9. Minus 2 comma 9.
Minus 2 comma 9.
Means use the distance formula for that, like x plus 2 whole square plus 0 minus.
Yeah, so 2 minus 2 whole square, so 16, and plus 14 square 196, It will be root of root 53, right?
Yeah. 196. Yeah.
And then
After going that, again use the distance formula for x for that one and the point 2 comma minus 5.
means and then
X minus 2 whole square plus 0 plus 5 whole square.
acha, x minus 2 whole square plus 0 plus 5 whole square, right?
Yeah, plus 5 whole square.
Huh?
Yeah.
So I'll get root of x square
X,
minus
one second, wait, you can
4x.
just put it like that. I had to do one thing. After putting it like that, we have one more equation. Like we took minus 2 comma 9 and x comma 0. And writing the distance formula between those two and what was that? And equating them and squaring them, I got the x value.
Acha, okay. So okay, I'm getting. So you means you did x. So you'll equate these two. X square minus 4x plus 21 is equal to 212, and from there.
Not from there. Like we had 2 points, right? Minus 2 comma 9 and 2 comma minus 5.
Yeah.
First, I used the distance formula minus 2 comma 9 and x comma 0, and I used the distance formula for those two, and I used distance formula for 2 comma minus 5 and 0. I mean x comma 0. I equated them and I squared them. I got it.
Okay, so x comma 0. So you will get x minus 2. So x plus 2 whole square and then 0 minus 9. So what there'll be 81 under the root I'm removing. And then that'll be similar to x minus 2 whole square
plus 0 plus 5 whole square.
0 minus 5
X square plus 4 minus 4x plus 25.
Just to get x plus 2 whole square.
Under the root.
From here you can do it, right?
Yeah.
So x square plus 4x plus 4 8185 is equal to x square minus 4x plus 4 plus 25 29. And then remove x square and then say 8x is equal to 29 minus 85. This way, right?
Yeah.
Then x is minus 8, right?
Yeah.
Minus 8.
No, minus 7. Minus 7. It will be minus 7. You did a mistake. Calculation mistake.
29 minus 85. Wait. 81 plus 4, 85. 25 plus 4, 29. 29 minus 85 will be 55 plus 1. Acha, okay. 7. Minus 7. Okay.
The points are minus 7 comma 0.
Distance between points, this was easy. This is formula based. Okay, this one. This one was the area of the triangle whose vertices are minus 6, 2, minus 4, minus 6, and 2, comma 5. Okay, fine. So minus 6, comma 2 will be somewhere minus 6. Okay. Minus 6 will be somewhere here, let me say. And comma minus 2. Achha, so comma minus 2 will be somewhere here. So here will be A. Minus 6, comma minus 2, correct? And then B again minus 4, comma minus 6. Minus 4, let me say it will be somewhere here. Minus 6 will be somewhere here. So somewhere here will be B. Okay, minus 4, minus 6. And then the final point is minus 2, comma 5. Minus 2 will be, let's say, here. And comma 5. Wait, minus 2, oh, sorry. Minus 2 will be here. Comma 5 will be, say, here. And then this is C, which is minus 2, comma 5. And then you're making a triangle. So triangle here. Triangle here. And then this. Okay, so you have to find the area of this triangle. How do you go about it? Anyone? Shreyansh, did you do this one? Shreyansh?
Yes.
Did you do this one where you had to find the area?
In the area.
The area of the triangle whose vertices are a comma minus 6 minus 2, b minus 4 minus 6 and 2 comma minus 5. This was the first, second,
Yeah.
third, fifth question, I think.
Yes.
So how do you do this?
I found the distance by the distance formula, and then I
Heron's formula.
applied it on the half into base into height.
Half into base into height, how do you know? You don't know whether it's a right angle triangle, right? You'll have to use Heron's formula. Okay, so you found a distance, it will be minus 2 minus 6. How much? 4 now. So it will be 16. 16 plus 5 minus 2, 49 under the root. And then 16 plus 50, 76, root of 75. It will be 5 root 3 will be this side. Then minus 6 minus 2 and minus 4 minus 6. So this will be 4 plus minus 2 minus 6 again 4, 16 this time. Root, and this will get you 2 root 5, right? 2 root 5 this way. And then minus 2 comma 5 and minus 4 comma minus 6. So minus 4 minus 2 you will get then 4 as the square. And minus 6, 5 you will get 11, 121. You will get root of 125, which will be 5 root 3. Oh. Okay, so we have an isosceles triangle over here. Now, how can we figure out that it will be a right angle triangle if it is? You can use the smallest side. The smaller sides are 2 root 5 and 5 root 3. So the squares will be 20 and... Okay, root 125 will be 5 root 5 now. 5 root 5. So you will use 5 root 3. 20 plus 75, it is... So it's not a right angle triangle because the squares are not adding up to the square of the other side. Okay?
So how can we go with that?
Then you'll have to use Heron's formula, which like it is used when you just know the sides and sides of the triangle. Okay, so that is so semi-perimeter. So taking out the perimeter will be a bit too much. It will be 5 into root 3 plus root 5. You get 7 root 5 plus 5 root 3 under 2. See, Heron's formula is simply if the perimeter is if there are the 3 sides of a triangle A, B, and C, and you don't know if it's a right angle triangle or not, so you can't use half into base into height. So what you will use in this case is A plus B plus C divided by 2, which you can see will be half the perimeter or semi-perimeter multiplied by
S minus A into S minus B into S minus C.
A into S minus B into S minus C. Yeah. So from here, if it's not a right angle triangle, this is a formula which you can use to find out what will be the answer. Fine?
Yeah.
So too much of the worksheet now. Let us go on to more about cubic polynomials and the synthesis method of solving quadratic polynomials. Now, or any polynomials for that. So we saw that ax square plus bx plus c is the standard form of a quadratic polynomial where a, b, and c are all constants. But since it's a cube, it shouldn't be there'll be one more term. So the standard form of that will be ax cube plus bx square plus cx plus d, this is a new thing, is equal x cube plus bx square plus cx plus d. So this will be the standard form of a cubic polynomial. Now we had learned that there can be at most two roots of a quadratic polynomial, but Rajwal, can you guess what will be the case for cubic polynomial? At most, how many roots can it have?
I don't know.
See, quadratic polynomial, the highest is 2, right? Ax square. And it has 2 roots. So from that, take a guess. 3, right?
I'm not.
It will be 3.
Yeah.
So it have so you can remember by this. If 2 is the largest exponent, there will be 2 roots. And if 3 is the largest exponent, there will be 3 roots. If n is the largest exponent, there will be n roots. Fine?
Fine.
Now there isn't any cubic formula as such through which we can solve any cubic equation. What we can do by factorization, which is not that difficult, which is kind of everyone's cup of tea. Okay, but before that, one property we can also learn is, now alpha and beta were the two roots of a quadratic polynomial. But this time I'll incorporate a third Greek letter as a root. Let it be gamma. Gamma is somewhere, it's like a curved Y. So if alpha, beta, and gamma are the roots of a cubic polynomial, yeah. So the values which can satisfy. Just a minute. If you equate it to 0 and you put those values, alpha, beta, or gamma, all of them will get you 0, giving a cubic equation. Then alpha plus beta plus gamma. This will be minus of b by a. Then alpha into beta plus beta into gamma plus alpha into gamma. This will be c by a, and alpha into beta into gamma, that will be minus of d by a. D. So this is, you can, we are just finding a property of the roots. There was alpha, and for the quadratic polynomial case, was alpha plus beta is minus b by a, and alpha into beta is c by a. But in this case, this is the formula. And this corresponds to such a polynomial. Fine?
Shakti, can you make the camera down because I cannot see the last line. Okay. Yeah, now it's okay.
Hopefully it doesn't fall. Okay, got it, everyone?
Yeah, I got it.
Okay, so now we had learned yesterday that if there are any two numbers which I choose, alpha and beta, now not taking them as the roots, now just taking them as any random numbers, then the square of that will be alpha square plus beta square plus 2 alpha beta, right? But if I want the cube of alpha and beta, see, now I know the square. Otherwise, there's a formula, but still I'll show how we got. So we know that this will be alpha plus beta whole square into alpha plus beta, right? Because it's alpha plus beta whole square into alpha plus beta raised to 1. And we know by exponents and powers, if we take a leaf from that book, and when you multiply the same base, but different exponents, we'll add the exponents. So we'll get alpha square plus beta square plus 2 alpha beta into alpha plus beta. Okay. So alpha square into alpha will get me alpha cube. Alpha square into beta will get me alpha square beta. Beta square into alpha will get me beta square alpha. Beta square into beta will get me beta cube. 2 2 alpha beta into alpha will get me 2 alpha square beta, and 2 alpha beta into beta that will get me 2 alpha beta square. Is it visible? All the lines?
Yeah, 1 second, we'll copy it down.
See, when it's like this, you have to just multiply each term with the other term. So alpha square you have to multiply with both the terms, beta square you have to multiply with both the terms, 2 alpha beta you have to multiply with both the terms. Now, alpha cube and beta cube, there's nothing else to keep them alike. But you can see there's one alpha square beta here. There's a 2 alpha square beta here. And they have an addition sign. So I can make them 3 alpha square beta. Similar case is beta square alpha plus 2 alpha beta square. That'll get me 3 alpha beta square. Fine. So this is the formula for alpha plus beta the whole cube. Fine.
Yeah.
Okay, everyone, did you note it down? Okay, fine. So I'm giving an example of a cubic polynomial. Say I have the cubic polynomial x cube minus 6x squared plus 11x minus 6 is equal to 0. We have this is also called cubic equation. Fine.
Yeah.
So what we do in these cases is, see, one factor will be, okay. So we should look at the last constant term, which is minus 6. So the factors of minus 6 will be plus 1, plus 2, plus 3, minus 6, minus 1, minus 2, minus 3, and minus 6. Now, take any factor. First, you'll have to do trial and error, but say, let me take x is equal to 2. Fine? X is equal to 2, let me take. Now, if x is equal to 2, that means x, so I can divide the whole thing by x minus 2. Because if x minus 2 is equal to 0, only then will I be able to get that x minus 2 is equal to 0, then I'll get x is equal to 2. Fine? So take any factor of the constant, any integral factor, and equate it to x and try to see if it's working out. So let x is equal to 2. Now, what I do is, I divide x cube minus 6x square plus 11x minus 6 by x minus 2. Now, how will I divide it? You'll see. So, I want to remove this x cube from here. So, say I put one x square first. So, x square means x minus 2 into x square will mean x cube minus 2x square. So, we will put one minus and then we put a plus here. Because that is what we do. Like when we are dividing polynomials, we put a minus here. If it's positive, we put a minus down. If it's negative, we put a plus down. So we'll actually do first minus 6 plus 2. So we'll get 4x square plus 11x minus 6. Right? Or am I doing something wrong? Am I doing something right? Is it fine? Is it fine, everyone?
Yeah. Yes.
Okay, fine. So 4x square is 11x minus 6. And then I can put, I'll put minus 4x because then I'll get minus 4x square. and then I'll plus it. Wait a minute. Should I put minus 4x or plus 4x?
Shouldn't it be minus?
You can put plus so that the sign can change.
It should be minus. It should be minus 4x square, right? Minus 4x square.
If you put minus 4x square home, then it will become a plus sign, and then you'll get 8x square. Right? You'll get 4x square. So if you put minus 4x square, it'll become another plus. Become 4x square plus 4x square. So you'll have to put plus 4x, right?
That means 2 is not a factor.
2 is not a factor. No, still let me see. If I put 4x here, then I'll get 4x square minus 8x.
Like we could check it if we put 2 in that equation, right? In the place of x. If it gives us 0, then we could use it.
Okay, 11x minus 8x. Okay, I think I can. If you put a plus over here, it will become 11x plus 8x, 19x. But if I put minus 4x, okay, let me put minus 4x, then I'll get. Then 4x square will get cancelled. And then I'll get on this side 3x minus 6. And then I can put 3. Right?
One second.
11x minus 8x will get me 3x. 3x minus 6. And x minus 2, you can see there will be plus 3. Right? Or there is something wrong. Shreyansh, can you see any mistake or something? Wait, let me see.
I don't see any mistake.
X cube minus 6x square plus 11x minus 6. Let me try doing the actual multiplication. X minus 2 into x square minus 4x plus 3. So that will be x cube, x minus 4x square, the minus 6x square, then plus 3x minus 3x plus 3x minus 8x. That will be 5x. Yeah.
It will be x square plus 4x plus 3, right?
Let me put plus and see. Plus. If I put plus 4x, then it will be x into plus 4x will be 4x square. And minus 2 into 4x will be minus 2x square. Hey, that'll get me? No, not plus. I think it should be minus only, because only there will get me minus 6x square. Now, it will be minus 2x square here. And I need a minus 4x square to get it. Getting me?
So why have you written there x square plus 4x?
Here minus, nah. Here is minus, here is minus. Let me.
I got the quotient as x square minus 4x plus 5. Is it? It's correct, right? Did you get the same? I got the quotient as x square minus 4x plus 5.
That's 5 or 3? 3 should be, now 11x minus 8x will be 3x minus 6, and then that will be x minus 2. Let me see with x square minus 4x plus 3, x cube here, and then x into minus 4x square, minus 2 into x square minus 6x square, so I'll add them up. And then x into 3x, minus 2 into minus 4x plus 8x, so 3x plus 8x, 11x. Now I'm getting. Minus 2 into 3, minus 6. So this is same as this one. So we found out that x minus 2 is a factor. Okay?
Yeah, I got it.
Now, so we know that 2 is a factor. We put x is equal to 2 and we got this. Now next. X square minus 4x plus 3. Anyone can tell me what this is similar to?
X square minus 4x plus 3.
Is it not similar to a quadratic equation?
It is.
You can solve with the quadratic formula. So x square minus 4x plus 3 will be x square minus x minus 3x minus 3. I'm solving by factorization. So I'll get x into x minus 1, x minus 3 into x minus plus 3, x minus 1 is equal to 0. So 2 more values of x I'll get 3 and 1. Fine? Fine and 1? So now you can observe all the values which will satisfy the cubic equation. They have to be factors of this last coefficient. Now this is for when it's x cube. But if you want others also, there's another way with which we can not only solve x cube, but you give any power, any polynomial in x of any degree, that can be solved with another method, which is known as the synthesis method. Now, to explain what the synthesis method is, let me take another polynomial, x raised to 4 this time minus 6x cube, x raised to 4 minus 6x cube minus 26x squared plus 138x minus 35. I'm not equating it to 0 just yet. So, because you'll find the factors like in forms of x, you can say. Okay, so we'll see the constant minus 35 and the factors you will get is 1, 5, 7, 35, minus 1, minus 5, minus 7, minus 35. So all these will be the factors. Now, divide the factors of minus 35 by those of the coefficient of x raised to 4. So we'll get a few numbers, but sometimes if 2x raised to 4 was the case, then we have got say 1 by 2, 5 by 2, 7 by 2, 35 by 2, minus 1, and then negative. But since in this case it's only 1 x raised to 4, they will remain same. You're just dividing the factors by these factors, and these factors are same, so there'll be nothing changed in them, right?
Yeah.
Getting it, everyone? Shreyan, Sheshwant, Prajwal, Rayan, Ajinkya, all of you getting it?
Yeah.
Shaktam,
Yeah, Shreyansh.
why did you write minus 5 here?
We want the integral factors. Now, we have not only the natural factors, but there are also integral factors. So, all the integer forms we can find, we want to find the factors in. So, minus 1, 1, 5 minus 5, 7 minus 7, 35 minus 35.
Okay.
Usually, we are prone to only finding, we are told to find the factors of any number, just their addition, but we are going for integral factors. So integral factors, if you multiply minus 1 with another integer minus 35, you'll get 35, right?
Yes.
Okay, fine. So now this is a bit taxing, but still but this is the most efficient method to solve any polynomial in a degree yet. Okay, so let me take 7. Let me take a number 7. Now first, let me make a table with all the numbers behind the thing of x. So let me explain what I meant. See, behind x4, the x raised to 4, the coefficient of x is 1. X raised to 4 is 1, right? So I'll put a 1 over here. The coefficient of x cube is minus 6. I'll put minus 6 over here. If I put, and the coefficient of x square is minus 26, which I'll put here. That of, okay, and I'll require a bit more space. We're taking the coefficient. So we're getting 1, minus 6, minus 26, 138, and minus 35. Now let me put a 7 over here. And let me draw something here. Okay. So the first number here in which is 1, we'll bring it down. Now what we do here, we multiply 1 with 7. Now when I multiply 1 with 7, I'll get 7. I'll put it here and add 7 and minus 6 to get 1 again. Fine? Then when I multiply 1 with 7 again, I'll get 7. 7 plus minus 26 will get me minus 19. Minus 19 into 7 will get me minus 1. How much? 70. 70 plus 63 minus 133. Minus 133, I'll get 5. 5 into 7 will get me 35. And 35 plus minus 35 is 0. So our aim exactly in this is to get 0 over here. Now when we get the 0, we can say that 7 is a value which will satisfy an equation which will be formed if I equate this polynomial to 0. So if I put 7 raised to 4 minus 6 raised to 7 cube, all the other places, then you'll get 0. Fine. Now I have 1, 1, minus 19 and 5. So what I do now is make another table only with these 4 values. 1, 1, minus 19 and 5. Okay. 1, 1, minus 19 and 5. Now what I do again is, see, factors of 1 plus 1 minus 1. So the factors of 5 will remain the same. The only factors of 5 will be 1 and 5. So say I take, what should I take? I'll take minus 5 over. So I'll take minus 5 over here and repeat what I did last time. So I'll bring 1 down and then I'll get minus 5. 1 minus 5 minus 4. Minus 4 into minus 5 will get me plus 20. 20 into minus 19 will get me 1. 1 into minus 5 will get me minus 5, and here again I'll get 0. Now, when you get this 1410, you can do the same thing again. You can make a table and then you can take, what should I take? 1 or minus 1. Let me take 1. Okay, so let me take 1. 1 down, 1 into 1. Minus 3 into 1. Fine, let me take minus 1 and see what happens. 1 down again, then minus 1, minus 5, minus 5 into minus 1. I don't think this will happen for these ones, but let me see. So when you have 1, minus 4 and 1, what you can do is make a quadratic polynomial, taking the coefficients as 1, minus 4, no, 1, minus 4 and 1. So 1 and minus 4 and 1, what I mean is you make a quadratic equation, x square minus 4x plus 1 is equal to 0. Now here you can determine the roots 4 plus or minus 16 minus 4 divided by 2. You get 4 plus or minus root 12 by 2. Root 12 will be 2 root 3. So you get that 2 plus root 3 and 2 minus root 3. So since the degree was 4, we got 4 values. We got 7, 2 plus root 3, 2 minus root 3. And what was the second value we had taken? Plus 5 or minus 5? Minus 5. So these are the zeros. Now when I say a value is a zero of a polynomial, I mean that when I equate the polynomial to 0, these values, if I put in the equation, they will satisfy the equation and get me 0, which is what I want. Okay? Fine, everyone? With what we did, or any doubts?
It's fine.
Shreyansh, Vedant, Reyansh, Yashwant,
Yeah, it's fine.
Ajinkya, any doubts?
I didn't understand. How did you do this?
Do which part? Which part? Which part didn't you get?
Like I didn't understand how you solve it entirely.
Uh, okay, I'll just do just once more.
Thank you.
So, see, if I can put a 1 here, right? It will not change the value anything. So I can put 1x raised to 4 minus 6x raised to cube 3 minus 26x square plus 138x plus 35. Fine.
Yeah.
Now let me take a table. 3, 4, 5, 6.
Okay.
Now let me list these numbers. Here 1, here minus 6, here minus 26, here 138, here minus 35. Okay?
Okay.
Now let me see what are the factors of minus 35. So factor of minus 35 will be minus 1 and 1, minus 5 and 5. See, we are finding integral factors because you used to just getting a natural number and telling it's positive factors, but there will be negative factors also. Why? Because we are operating the integer value of the factors. Okay.
Okay. So it'll be negative. The factors will also be.
Minus 5, 5. Then I'll get minus 7, 7 and minus 35, 35.
Okay.
So now we'll have to do a bit of trial and error in this. But for your sake, let me take 7. Let
Okay.
me choose the number 7. Okay.
Okay.
Now I'll put it over here. So the
Okay.
first value which I have, let me bring it to the second part down.
Okay.
Now let me multiply 1 with 7. 1 with 7 will get me 7, right?
Yeah.
So minus 6 plus 7, I'll get
Minus
1.
42. Minus 6. Minus 6 into 7. 6
Okay,
plus.
not into, plus.
Okay. Okay.
Minus 6 plus 7.
Okay. Which is 1.
1. Good. So we'll get 1. And then 1 into 7 again we'll do. 1 into 7 will get me 7.
Okay.
Then minus 26 plus 7 will get me minus 19.
Okay.
Minus 19 into 7 will be minus 133.
Okay.
Then 138 minus 133 will get me 5. 5 into 7 will be 35. And minus 35 plus 35 is 0. So our
Okay.
aim is to get 0 in this last box. Fine.
Fine. Understood.
Now we
Understood.
have 1, 1, minus 19 and 5. Let me put them in another table. 1, 2, 3, 4, 5. So 1, minus 19 and 5.
Okay.
So 5 is a prime number. So
Yeah.
minus 1. So its factors will be 1, minus 1, 5, minus 5. Okay.
Yeah.
Let me take minus 5.
Okay.
Minus 5 over here.
Okay.
So 1 again I'll bring down. I'll get, wait a minute. Wait. I'll put small to 1, 1, minus 19 and 5. So I'll bring the 1 down again.
Yeah.
1 into 5 again, I'll do 5.
Okay.
Achha, I took minus 5 now. Sorry. So 1 into minus 5 will get minus 5.
Okay.
1 into minus 5, 1 plus minus 5 will get minus 4. Minus 4 into minus 5 will get plus 20. 20 minus 19 I'll get 1. 1 minus 5 I'll get minus 5. And then I'll again get 0.
Okay, understood.
Now when you have 1, minus 4 and 1, so we know that the standard form of quadratic polynomial is ax square plus bx plus c, right?
Yeah.
So now, since you have 1, minus 4 and 1, you can replace a, b and c with 1, minus 4 and 1 respectively, okay?
Okay.
So what you get is 1x square, which is x square, minus of 4x plus 1. Now equate this to 0. And with the use of the quadratic formula, you can get that will be 4 plus or minus root of minus 4 square 16.
Yeah.
Right?
Yeah.
And minus, and then minus 4ac. So here our a is 1, so we don't do anything. Minus of 1 into 4 I'll get, right?
Okay. Yeah.
divided by 2. 2 into 1. Fine.
Yes.
Then I'll get 4 plus or minus. Now, root of 12 is root of 4 into 3.
Okay.
Now, root of 4, if it is the square root of 4 into 3, then you can say it is the square root of 4 multiplied with the square root of 3.
Okay. Square
And
root
then
of
you can then you know that the square root of 4 is
16.
square root, not square.
2.
2. So you get 2 root 3. Okay?
Yeah.
So you can make root 12, you can make it 2 root 3 because root 4 is 2, and then you can do and root 4 into root 3 is this is a fact. If there are two numbers, alpha and beta, then root of alpha into root of beta will be also the square root of alpha into beta. Okay?
Okay.
Now 4 plus or minus 2 root 3 divided by 2. So 4 divided by 2 will be 2. And here will be 2 plus or minus root 3, right?
Yeah.
Which means two more values. I can get 2 plus root 3 and 2 minus root 3. That is what it means plus minus, right?
Okay.
So you remember these values. We got 7, it's satisfied. Minus 5, satisfied. And 2 plus minus root 3, satisfied.
Okay.
Now got it?
Yeah, got it.
Okay. Got it, everyone? Everyone got it?
Yeah.
Okay, then let's end it with a quiz. Hold on. Okay, now some of you weren't there when I was telling the others about how the assessment will take place tomorrow at 6 p.m. But I'll repeat it once more. So at 5:59 p.m. tomorrow, all of you will have to keep your mails ready because you will get a Google form on your mail. All of you will get a Google form on your mail, and they will not only contain MCQs or true or false questions, but then there'll be also a few subjective questions in which I will want to see how you came about the final answer. So that is why some of them will be, as in there'll be file upload questions in which, and then means, let me tell you this, I'll not put question by question and make your job too difficult by me. If there was a question which required only a little bit of your page space, I'll make you scan it again and again. But instead, I'll just give you one. I'll first do all the MCQs and true false first. Then I will put one. I'll put this thing. Yeah. In the name of the question, I'll put a link which will lead you to a document, and then all your uh, means you'll be able to put a maximum of 5 to 10 pages. So all of in that link, finally when you're done with the whole thing, you'll scan it and you'll upload it in the Google form only. Right? Got me? Everyone?
Yes.
Okay, fine. So I am starting it right now. Just a minute. So I'm sending the link in the chat box. Yeah, go to this link. Okay. Everyone join. I'll come in a few minutes. Okay, I can see that a few people have joined the quiz. Oh, 7 have joined. 1, 2, 3, 4, 5, 6. Okay, should I start? Everyone has joined? Yashwan, Shreyansh, Vedant, Om, Ryansh.
Yeah.
Prajwal. Okay, just give me a minute. Okay, all the best, everyone. I'm starting the quiz now.
Can you send the link one more?
Sent it. What, Tom?
No, I was asking you to mute yourself.
stop the game now?
Yeah.
Well, can we stop the game? Just yeah, what happened?
Yeah, I was just asking, can you mute that site? It's too loud.
Now better?
Yeah, now it's fine. I'm done, by the way.
Yashwant, Yashwant, can we stop the game? Yashwant, Prajwal, because it doesn't seem that your scores are.
Yes, you can stop the game. I thought that was another quiz and I came it again. I finished fast only, first time.
Oh, okay. So I'm ending the game. I'll discuss one or two questions. So the leaderboard shows third Shreyan, second Yashwant, and first is Om. Okay, so now let me see which questions were not. What can the roots of a quadratic equation be called? Zero solution or x-intercepts. This was a tick box question. You had to not only select one of them, but select all of them. Longest questions. Sachin and Ram. Acha. This was, by the way, a question which had come in. It was means JEE Mains and JEE Advanced was not there until 2012. There was before that AI Triple E was different and JEE was different. So, but then both of them were merged in 2012. So you can in a way say that this question had come in JEE Main 2011. And then a few more. I think a lot of you may have on the 11th question. I don't think many of you must have got it right because that required a little bit of thinking. So in this one, you have to replace as in x square minus 6x minus 2 is equal to 0. So you can also say that it's alpha square minus 6 alpha minus 2 is equal to 0. Let me just tell you how you can go about it. Okay. So let alpha and you're audible. Let alpha and beta be the roots of the equation x square minus 6x minus 2 is equal. Okay, fine. Is the class over? Just getting over. So alpha square is 6 alpha square minus 6 alpha minus 2 is equal to 0. You can say by replacing x with alpha, and then you can say alpha square is 6 alpha plus 2. Then you can raise each side 2 by 5. Means you can make it alpha raised to 10 is equal to 6 alpha raised to 9 plus 2 alpha raised to 8. So basically what I'm doing in this case is I'm multiplying the whole each side with alpha raised to 8. So then I'm getting that alpha raised to 10 is 6 alpha raised to 9 plus 2 alpha raised to 8. And then similarly I can say that beta raised to 10 is 6 beta raised to 9 plus 2 beta raised to 8. So then, as I told you, if it's something, for example, the line equation that we were discussing yesterday, and we can say that alpha raised to 10 minus beta raised to 10 is 6 into alpha raised to 9 minus beta raised to 9. So if you subtract the equation and you write them down, you can see what I mean. Plus 2 into alpha raised to 8 minus beta raised to 8. So now since we know that like if it's a with subscript n is alpha raised to n minus beta raised to n, so what we can, I'm just replacing, so I'm getting a raised to 10 is equal to 6 a subscript 10 is equal to 6a subscript 9 plus 2 into a subscript 8. So then I can bring the 2a subscript 8 to the other side to get a subscript 10 minus 2 subscript a subscript 8 is equal to 6a raised to 9. And then when I divide the whole thing by 2a subscript 9, I'm getting 3. Fine? Fine, everyone?
Yeah.
Oh, fine?
Yes.
Okay, fine. So I won't be sending a worksheet today. All of you practice and revise the concepts for tomorrow's assessment. Okay?
You will upload the today's recording on YouTube.
I'll see what I'll do. Okay? Because I'm not sure if the network will be there. Fine? Okay, stopping the recording now.
Thank you.
Thank you. Thank
Oh,
you,
shit.
everyone.